Hello everyone, I am Mr.P.Y.Kumbhar. Today we want to see the spread spectrum multiple access, that is Ssma. The learning outcome of this topic is at the end of this session, student will be able to explain the concept of spread spectrum multiple access, that is Ssma. The contents of these topics are, first of all we want to see the introduction. Then what is the means of a FHMA, that is frequency hopped multiple access. Then we want to see the code division multiple access, that is Cdma. And lastly we want to see what are the different features of a Cdma. Now first of all see the introduction. Ssma, that is spread spectrum multiple access, uses signals which have a transmission bandwidth that is several orders of a magnitude greater than the minimum required RF bandwidth. Ssma also provides immunity to multipath interference and robust multiple access capability. Ssma is not very bandwidth efficient when used by a single user. However, there are many users can share the same spread spectrum bandwidth without interfering with one another. Spread spectrum system becomes bandwidth efficient in a multiple user environment. It is exactly the situation that is of interest to wireless system designers. Basically, there are two main types of a spread spectrum multiple access techniques. The first one is a FH, that is a frequency hopped multiple access, and second one we shortly called as a DS, that is direct sequence multiple access. Now this DS, that is a direct sequence multiple access, is also called code division multiple access. Now this figure 1 shows the frequency hopped multiple access, that is FHMA system. Here there are basically, this diagram is shown in a 3-axis representation. In a 3-axis, out of this 3-axis, one axis is shown as a time, second axis shown as a frequency, and third axis we show as a code. Here the channel is divided into number of users, there is a n number of users. Now this figure illustrates how FHMA allows multiple users to simultaneously occupy the same spectrum at the same time, where each user dwells at a specific narrowband channel at a particular instance of a time based on the particular PN code of the user. Now we want to see the frequency hopped multiple access, that is FHMA. Here FHMA, that is a frequency hopped multiple access, is a digital multiple access system in which the carrier frequency of the individual users are varied in a pseudo-random fashion within a wideband channel. The digital data of each user is broken into uniform size bursts which are transmitted on different channels within the allocated spectrum band. The instantaneous bandwidth of any one transmission burst is much smaller than the total spread bandwidth. The pseudo-random change of the channel frequencies of the user randomizes the occupancy of a specific channel at any given time, thereby allowing for multiple access over a wide range of frequencies. In the FH receiver, a locally generated PN code is used for the synchronize the receiver instantaneous frequency with that of the transmitter. At any given point in a time, a frequency hopped, that is FH, signal only occupies a signal that is relatively narrow channel, since that is called as a narrowband FM or FSK is used. The difference between the FHMA and the traditional FDMA system is that the frequency hopped signal, that is FHMA, changes channel at rapid intervals. If the rate of change of the carrier frequency is greater than the symbol rate, then the system is preferred to as a fast frequency hopping system. But if the channel changes at a rate less than or equal to the symbol rate, then it is called as a slow frequency hopping. A fast frequency hopping may thus be thought of as an FDMA system which employs frequency diversity. FHMA system often employ energy efficient constant employ modulation, constant envelope modulation. Inexpensive receivers may be built to provide non-coherent detection of FHMA. This implies that linearity is not an issue and the power of multiple users at the receiver does not degrade FHMA performance. A frequency hopped system provides a level of security, especially when a large number of channels are used, since an receiver that does not know the pseudo-random sequence of frequency slot must retune rapidly to search for the signal wishes to intercept. In addition, the FS signal is somewhat immune to fading since error control coding and interleaving can be used to protect the frequency hopped signal against deep fade which may occasionally occur during the hopping. Error control coding and interleaving can also be combined to guard against the which can occur when two or more users transmit on the same channel at the same time. Bluetooth and home RF wireless technology have adopted FHMA for power efficiency and low cost implementation. Now we want to see the Cdma, that is code division multiple access. In code division multiple access, that is Cdma system, the narrowband message signal is multiplied by a very large bandwidth signal called the spreading signal. The spreading signal is a pseudo noise code sequence that has a chip rate which is orders of magnitude greater than the data rate of the message. So whatever in a CDM system which are shown in the figure 1 use the same carrier frequency and may transmit that is a simultaneously. Now each user has its own pseudo-random code word which is approximately orthogonal to all other code words. The receiver performs a time correlation operation to detect only the specific desired code words. All other code words appears as a noise due to decorrelation. For detection of a message signal, the receiver needs to know the code word used by the transmitter. Each user operates independently with no knowledge of the other users. In CDMA, the power of multiple users at a receiver determines the noise floor after decorrelation. If the power of each user within a cell is not controlled such that they do not appear equal at the base station receiver, then it is near-far problem occurs. The near-far problem occurs when many mobile users share the same channel. In general, the strongest received mobile signal will capture the demodulator at a base station. In a CDMA, stronger received signal levels raise the noise floor at the base station. Demodulation for the weaker signal, thereby decreasing the probability that weaker signals will be received. To combat the near-far problems, power control is used in most CDMA implementations. Power control is provided by each base station in a cellular system and assures that each mobile within the base station coverage area provides the same signal level to the base station receiver. This solves the problem of nearby subscriber overlapping the base station receiver and drawing out the signals for away subscribers. Power control is implemented at the base station by rapidly sampling the radio signal strength indicator, that is RSSI levels of each mobile and then sending a power change command over the forward radio link. Now the features of a CDMA is as follows. The first one, many users of a CDMA system shares the same frequency, either of TDD or FDD may be used. Second one, unlike TDMA or FDMA, CDMA has a soft capacity limit. Increasing the number of users in a CDMA system raises the noise floor in a linear manner. Thus, there is no absolute limit on the number of users in a CDMA. Rather, the system performance gradually degrades for all users as the number of users is increased and improves the number of users is decreased. Third one, the multipath fading may be substantially reduced because the signal is spread over a large spectrum. So if the spread spectrum bandwidth is greater than the coherence bandwidth of the channel, the inherent frequency diversity will mitigate the effect of small scale fading. Fourth one is the channel data rates are very high in a Cdma system. Consequently, the symbol duration is very short and usually much less than the channel delay spread. Since PN sequences have a low autocorrelation, multipath which is delayed by more than a chip will appear as a noise. A rake receiver can be used to improve reception by collecting time delayed version of the required signal. The fifth one is since Cdma uses the core channel cells, it can use microscopic spatial diversity to provide soft handoff. Soft handoff is a performed by the MSC which can be simultaneously monitor particular user from two or more base stations. The MSC may choose the best version of the signal at any time without switching frequencies. Sixth one is self-jamming is a problem in a Cdma system. Self-jamming arises from the fact that the spreading sequences of a different users are not exactly orthogonal. Hence, in the despreading of a particular PN code, non-zero contribution to the receiver decision statistic for a desired user arises from the transmission of the other users in the system. The near-far problem occurs at a Cdma receiver if the undesired user has a high detected power as compared to the desired user. The references for these topics are. Thank you.